there, and welcome back to the second tutorial for ROS. In our previous tutorial, we were able to use ROS to make a turtle sim move using our keyboard. In order to understand the workings of ROS and to give you an explanation of how we were able to achieve this, it is essential to understand the concepts of publishing and subscribing. In our previous ROS tutorial, the turtle teleop key node was the publisher, whereas the turtle sim node was the subscriber. They were communicating over a ROS topic, with the turtle teleop key node publishing the keystrokes on a topic and the turtle sim node subscribing to the same topic to receive the keystrokes. Now that we have those concepts covered, let's take it a step further. Let's say we want to publish data on a topic, that is, we want to move the turtle using code rather than keystrokes. For that, we're going to use the command ROS topic pub. So let's open a new terminal and enter ROS topic pub. And in order to run this command, we need three things. We need the topic, we need the message type, and we need the arguments. First of all, let's find the topic. We previously stated that the publisher, that is the turtle teleop key, and the subscriber, that is the turtle sim node, were communicating with each other over a ROS topic. We can visualize this relationship using the RQT graph. So, in another terminal, we're going to run the following command: ROS run RQT underscore graph, RQT underscore graph. This might take a couple of seconds to run. You should see the following window pop up, which shows the publisher node and the subscriber node communicating over a ROS topic that happens to be turtle1/command velocity. Now that we know the topic, we want to find the message type. Communication on topics happens by sending ROS messages between nodes. For the publisher, turtle teleop key, and the subscriber, turtle sim node, to communicate, the publisher and the subscriber must send and receive the same type of message. This means that a topic type is defined by the message type published on it. The type of message sent on a topic can be determined using the command ROS topic type. So in another terminal, we're going to go ahead and type ROS topic type slash, give a space between that, slash turtle one, that happens to be our topic. And you should get the following output. So our message type happens to be geometry messages twist. And now for the third thing, we want to find the arguments for this message type. So we're going to go ahead and we're going to open another terminal, and we're going to use the command ROS msg show geometry msgs. We can see that there are 3 linear and 3 angular components that are needed to define geometry messages twist. So now that we have found all 3 inputs needed for ROS topic pub, we can run the publisher command. We're going to go back over here to the terminal that we initialized earlier, and we're going to input the different things that we've found that are needed to run this publishing command. So you're going to go ahead and you're going to type the following. and you're going to run the following command. Okay, it seems like we have an error. Let me see if I can fix that. Move the space over here. Yeah, I seem to have misspelled geometry as well. My bad. And we've run the following command. So let's just analyze what we actually did over here. We ran the ROS topic publishing command that allows us to publish data. And this -1 causes the ROS topic to publish only one message and then exit. The turtle1 CMD velocity is the name of the topic to publish to. The geometry message twist happens to be the message type. The double dashes tell the option parser that none of the following arguments is an option. And these are the coordinates that are needed for the geometry message twist. As we remember, one was one was a batch of linear coordinates and one was a batch of angular components. So this command line basically sends a single message to the turtle sim telling it to move with a linear velocity of 2 and an angular velocity of 1.8 and then to exit. So let's just go ahead and see if there were any changes. And yeah, you can see that our turtle, it basically moved in an arc following this publisher command. So you may have noticed that basically this after this command was run, the publisher exited the command. But what if we want continuous motion? For that, we want the publishing command to keep running at a continuous frequency. So for that, we're going to go ahead and modify the above command a little bit. We're going to take that command and we're going to add a frequency of 1 Hertz for it to move. So right over here after the twist part, you're going to give a space. You're going to write down -R1. That's for 1 Hertz. And you're going to run this command. It seems like we have an error. Let me just run that again after making some changes. There we go. You can see that our turtle is now moving continuously, and instead of exiting the program, the publisher is continuously publishing data. We can also refresh the RQT graph to see how these changes are affecting the entire structure of the program. And you can see now there are 2 publishers. One publisher is the keystroke publisher, and one publisher is the publisher that is currently working. Turtle Sim is subscribing from both of these publishers, and the topic over which they happen to be communicating is turtle1 command velocity. So this will be it for this video, and I'd just like to add that these videos are intended to provide a more intuitive learning approach to mastering ROS and to accompany existing tutorials. All the information and code stated in this video can readily be found on the ROS wiki page, and I'll be sure to add a description below. Be sure to check it out whenever you get the time.